Hello, in this video we're going to review the laws of exponents, also called properties of exponents. So up here I just stated them, and let's just go over those laws very quickly. Any base A is going to stand for just any base, right? It could be a number, it could be a variable, it doesn't matter. Any base A to a 0 power is always going to be 1. Anything to the 0 power is 1 except 0 itself, right? So this is an important statement right there. 0 to the 0 is not equal to 1. It could be, but it's not always equal to 1, and that's a topic and a concept above our ability to understand as of now between Algebra 1 and Algebra 2, so we're going to leave it there. Just know that A cannot be 0, the base cannot be 0. Anything else but 0 to the 0 power would be equal to 1. Alright, then we have two same bases. Notice how I have an A and an A. So when we have the same number at the bottom as a base, with two different exponents, or for that matter, even if the exponents are the same, what would happen is when we multiply the bases, we add their exponent. So that would be m plus n. When you have a product that's brought to a power, you can actually distribute that exponent. Now, it's important to know that I'm talking about when those are multiplied only, right? For instance, if I would have A plus B to the nth power, well, this would not be equal to A to the n plus B to the n. That would not be true, right? So we cannot distribute an exponent over a plus or a minus. But when it's a product, when the two bases here are multiplied, then we can actually distribute that exponent. And so that would be A to the n, B to the n. When we have a base to a power that is itself brought to another power, that's a power to a power, we just multiply them together. So A is equal to m times n. When we have a negative exponent, that means we want the multiplicative inverse of whatever the base is. So here, if the base is an A over 1, right, A is like A over 1, then we want the multiplicative inverse, meaning we're going to flip that fraction around, and so that becomes 1 over A, but to that positive power now, so to the n. So again, a negative exponent just means we want the multiplicative inverse. So we're going to take the fraction and we're going to do the multiplicative inverse, so the reciprocal. And you're going to say, well, I don't see a fraction here, but that's the same thing as A over 1, right? Same thing. All right, when we have two bases which are the same, A and A, they have to be the same for that to be true, and they're divided, we're going to subtract the exponent. So that's the same as A to the m minus n. It is always the top minus the bottom, right? Negative exponent means we're going to move it. So here it was on top, we moved it to the bottom. Here it's at the bottom, I'm going to bring it up, and it's going to become a negative. When you have a fraction of some sort, whatever it is, to an n, we can actually distribute that exponent just like we could in the product here. So that would be the same thing as A to the n over B to the n. Alright, let's put that in action now. So those are the laws, and let's see how it works. First of all, I have 8 divided by 2. Well, that's just a fraction that needs to be simplified. 8 over 2 is 4, so that's done. Then we have a base A and a base A. When we have the same bases, we can subtract their exponent. So when we divide the same bases, we subtract their exponent. Just like we did here, right? We divided the same bases, so we subtracted m, the top one, minus the bottom one. So here it's going to be A 5 minus the bottom one, which is a 2. Now don't leave it like that. Go ahead and do that subtraction, right? Because we know what 5 minus 2 is. So 4a to the third. That will be your answer. Here we are multiplying, that's a product. And there is no exponent on the outside here, no exponent on the outside there. So we are just going to go ahead and multiply 5 times negative 1. We don't write the 1, but we know it's there, right? 5 times negative 1 is negative 5. And then when we multiply the same bases, right, we multiply them. When we multiply the same bases, we add the exponent. So 2 plus 6. So a to the 2 plus 6. And go ahead and do that addition. So negative 5a and 2 plus 6 is 8. So that will be your answer right there. Now we have a power on the outside. So because all of that is multiplied and divided, we can actually go ahead and distribute this exponent. So 3 to the third power. So I'm going to write it down first. Then I have x squared cubed. Remember when we said we have a power to a power, we multiply those exponents, right? So x to the second to the third, 2 times 3 is 6. Make sure you multiply and not add, right? This is not 2 plus 3. This is a multiplication. And then the 2 at the bottom here is also inside the parentheses to that third, so that's also going to be a 2 to the third power. Now simplify all of that. 3 cubed will be 3 times 3 is 9, times 3 is 27, and then x to the 6th over, and then 2 cubed is 2 times 2 is 4, times 2 is 8. And 27 over 8 doesn't simplify, so that's our answer. Now we have a product, right? All of those are multiplied, and all of those are taken to the negative 2 power. Now remember we said when we have a negative exponent, we're going to use the multiplicative inverse. We're going to take whatever we have, and we're going to flip it, right? Do the reciprocal. So this here is not a fraction, so I'm going to write it as 1 over 1. Now I'm going to take it and I'm going to flip all of that to make that a positive power of 2. So that will be 1 over 3 x to the 4th, y to the 5th. And that's now a positive power of 2 because I did the multiplicative inverse, right? And now that power of 2 has to be distributed to everything inside because it's a multiplication, not an addition anywhere. So we can actually distribute that exponent. Well, 1 squared is just a 1. 3 squared is 3 times 3, which is 9. X to the 4th to the second, that's a power to a power, so we're going to multiply the exponents. So 4 times 2 is 8, so x to the 8th. And then y to the 5th to the second, we're going to multiply the exponent, will be y to the 5 times 2 is 10. And that will be our answer. Okay. Here again, we have a negative exponent, so we're going to make sure that this is our m squared over 1. We're going to do the multiplicative inverse to cancel that negative here, so we have 1 over m squared, which is now to a positive second power because we did the multiplicative inverse, right, took care of that negative. And now we distribute that exponent because it's a division that we have, so we can distribute the exponent. 1 squared is just going to be 1, right? 1 times 1 is 1. And then m squared will be 2 times 2 is 4, so m to the 4th. Now, one common mistake is once we've done a few of those negative exponents, suddenly students will see a negative and say, oh, I need to flip that fraction. No, 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 no. This is not an exponent. That's just a negative number, right? It is not a negative exponent. That's not the same thing. So we're not changing anything. That's just a negative right there in the front. It's going to stay right there. 15 divided by 3, well, that's a 5. So now I have a 5 here. And then I have an x to the 4th divided by x. Well, this is like an x to the first power, right? And remember, when we divide the same bases, we subtract their exponent. So we're going to divide the same base here, so we subtract the exponent. It's always the top minus the bottom. So 4 minus 1 is 3, so that's x cubed. All right. We have a negative exponent here and a negative exponent here, so instead of doing the reciprocal here, I'm going to go ahead and distribute that negative exponent first to see what exactly would have to be switched around. So 3 to the negative 1, well, it doesn't matter really which way I do it. So let's do it the way we've done it earlier so that you don't get too confused. So I wrote it as a fraction so that I can take it now and do the multiplicative inverse. Excuse me. So that will take care of that negative. So I have a 1 over 3 x to the negative 3 y to the second, right? So I just take what I have, the way I have it, and flip it. And then that negative becomes positive, and now it's just all to the first power, so I don't need to write it, right? Anything to the first power is just itself, right? So that's not changing anything. However, the 3 stays down here. But this x has a negative power, so that x really should not be down here anymore. It should be moved up. So we're going to move that up in the numerator and make it a positive 3 now, right? We're going to take just the 1 over x cubed, just that one, and we're going to flip that one, just this one, because that's the only one that has a negative exponent. The y to the second, that's a positive exponent, so that stays in the denominator. And we can cancel that one, we don't really need it. 1 times x cubed is just x cubed, and then 3y squared. Now this one, remember we said that anything to the 0 power goes to a 1. So 4x squared to the 0 power, that whole thing is to the 0 power, so that whole thing becomes a 1. So just a 1. However, at the bottom, that 0 power does not get applied to my denominator, right? That's 2xy to the 5th, so that's going to stay there. Notice how the 0 power here is just applied to the numerator. And this here, we have a 0 power again. It's applied to all of that because all of that is inside the parentheses. So this one is just going to be a good old 1. Because anything to the 0 power goes to 1. All right?